I hope you are doing well today. Let's get into the concept development for Module 5, Lesson 7. So today we are still working on volume. Volume, remember, is the amount of space a 3D object can hold. Right now, specifically, we are working on rectangular objects, right? Rectangular objects would have a length, a width, and a height, right? They go across, they go back, they go up and down. Think about a puzzle box. Think about an Amazon box when you get a gift. Think about the inside of your desk if you have that space inside your desk. Think about a swimming pool, right? So today, when we are working on this, we're going to continue to think about that, right? So the problem for today says that Emerlyn wants to make one planter that extends from the ground to just below her back window. So if you remember from the application problem, a planter is like a place you can plant fruits, veggies, plants, whatever it is, right? So she wants to make one that extends from the ground to just below her back window. So if we imagine that this is Emerlyn's house and here is the window, right? She wants her planter to go from the ground. Here's the ground. Let's make the ground green. Emerlyn, your house is pink apparently, right? She wants her planter to go from the ground, from right here, the ground, nope, from the ground right to where her back window is, right? That's the space she wants her planter to take up. The window starts 3 feet off the ground. So if the window starts 3 feet off the ground, then we know that the height is going to be 3 feet. We know that because she says that she wants it to go from the ground to just below her back window. So if the window starts 3 feet off the ground, then this space is 3 feet. She wants the planter to hold, not what I meant to do, she wants the planter to hold 36 cubic feet of soil. Cubic just means that cubed, but basically it means that we want the volume to be volume in this case. If it says 36 cubic feet of soil, we know the volume is going to be 36 feet cubed, okay? And our job today, what we need to do is to name one way she could build the planter so it's not taller than 3 feet. So this is a little backwards. Normally, when we are dealing with volume, we are looking for the volume, we are given the length, the width, and the height. Right? That's what normally what we're given. We're given this, we're given this, we're given this. Today, they gave us the volume already. They said the volume is going to be 36. That's what it says here. And we're given the height. It says the height is going to be 3 feet. So we're given this. I'm going to just get rid of our drawing for now. And so what we're tasked with doing, what's different from normal, is today we are being told that we need to find this and this. We need to find the length and the width. And again, whatever it is, whatever the length and the width are, they cannot be more than, like, if when I multiply them, it can't be more than 36. The reason being is because we're given that volume. We're told the volume is 36. So I need to find two numbers, this number and this number, that when multiplied together and then times 3 will equal 36. So let's say, for example, I decide that the length is going to be 2. And I can just decide it. It could be, you could just decide any number. Now I have 2 times 3. Oh, look, it's a smiley face. But if I have 2 times 3, that's 6. Now, can I multiply something by 6 to equal 36? That's the question we're asking here. 6, 12, 18, 24, 30, 36. Ah, yes, I could. I could multiply it by 6, and 6 times 6 will be 36. So as you can see there, I was able to find a length and a width that would fit. So one example, one way I could build, Emerlyn could build this planter is by making a length of 2 and a width of 6. Again, my goal here is to find a volume of 36 because that is what's given to me in the problem. The two things that it tells me is that my volume overall will be 36 and that my height overall will be 3. So I'm doing the ones that it tells me in the problem in this sort of maroonish color. Now the two things I still need to find are what I'm going to put in green here, right, are the length and the width. So what I did for this top one is I said, well, I know that I can multiply 2 and 3 to get 6. And if I multiply 6 times another 6, so if I make the length 2 and the width 6, I'll get a total of 36. Now, is there another way I could do this? Well, let's say I did 3 times 10, okay? Let's say I wanted to make my length 10. Now, I would have 10 times 3 would be 30. Is there anything I can multiply 30 by to get to 36? Like 30 times 1 is 30, 30 times 2 is 60. That's way over. So 10 is too big of a number. That doesn't work, right? You see what I'm doing here is I'm trying to figure out what numbers I can put in. Let's say I wanted my length to be the number 1. 3 times 1 is 3. Can I get 3? So I did 3 times 1, I got 3. 3 times what number for the width could equal 36? If there is a number times 3 that will equal 36, then this would work. And it turns out there is. 3 times 12 is 36. So if I did this, 1 times 12 is 12, times 3 is 36, that would work as well. So our goal is to come up with something like this. What is a way that I can make the volume 36, what length and width could I use? That's basically what it's asking you to do here, all right? So I just gave you 2 examples. See if you can come up with any more on your own, and as always, feel free to reach out with questions. Let's go to the next problem, shall we? So now, Emerlyn builds another planter, okay? She's really into planting. And this one is 3 feet long, 2 feet high, and 6 feet wide. So here, it's back to that sort of normal one where it gives us the volume, or it's asking us for the volume. It says it's 3 feet by 2 feet by 6 feet. 3 times 2 is 6 times 6. Oh, actually, look at that. She built another one that is 36 feet squared, or cubed, excuse me. So that was this part of the problem that I just did. She built a planter that's 3 feet long, 2 feet high, 6 feet wide. So here's my length, my height, and my width. That's a weird W, but we're just going to go with it. Then it says, she thinks if she doubles the length, the width, and the height, she will double the volume. Is she correct? Explain how you know. So in other words, what she wants to do is double, remember means times 2, the length, the width, and the height. And she thinks if she does this, then she's going to also double her volume. So what would double 36 be? So double 36 would be 36 times 2, right? That's what double means. 36 times 2 is going to be 74, I believe. Alexa, what's 36 times 2?
36 times 2 is 72.
Dang it, it was 72. All right, we all make mistakes sometimes. All right, so she thinks that if she doubles this number, and this number, then she's going to get a volume of 72. That's our goal. She thinks that she will double the volume. Double the volume will be 72 in this case. So let's find out. Well, we're going to need to double each of these. 3 times 2 would be 6. 2 times 2 would be 4. 6 times 2 would be 12. I'm starting to think this probably wouldn't be double because I know just on its own, 6 times 12 is 72. So I then need to still multiply it by 4. So no matter what I get, it is going to be greater than 72 because it's going to be 72 times another 4, or 72 plus 72 plus 72 plus 72. So no, it's not going to double the volume. It's going to more than double it. And when you think about it, there's a reason why. And the reason is that volume is not a two-dimensional space. It's not that I'm just saying, oh, I'm going to take this and I'm going to double it. I'm going to take this and I'm going to double it, but I'm also going to make the height twice as high, right? In this case, the length got twice as high. So the length went from just this to another one of these. The width went from just this to another one of these. So now we have something that already goes like this, right? All the way this way, all the way this way, all the way this way and back. That's already more than double. And on top of that, I'm also doubling the height. I'm also making this twice as high. So it goes from something that's just this big to something that if I just doubled the width, it would be out here. Then I'm going to double the length. So it went from being out here, let's see if I can move this, out here to all the way here to here and back, and double the height. So it would be way bigger. And you can try to visualize that, right? So I'll try at some point to draw something like this so we can see it together. But the answer is no, she is not correct. Because it is, I'm doubling more than just the length width. I'm doubling more than just one part of it, right? I'm doubling a whole bunch of things. And if you're still confused by that, the basic idea, the way that you can explain that, is just like what I did. I tried it. I said, well, she thinks that she's going to double the volume. I found what double the volume would be, right? Remember that volume was 36, so double that would be 72. And then I went ahead and I said, okay, well, if she doubled the length, it would be 6. If she doubled the height, it would be 4. If she doubled the width, it would be 12. And I went and I figured out that that would be way higher than this 72, which was my target number. So no, it would be more than double the volume. Hope that was helpful, scholars. As always, come ask me questions if you've got them. I love you, I miss you, and I'll see you soon.